Well, hello friends. Today we are going to hack on the kernel of Serenity, and I've been wanting to do this for a while, and it's going to be about path resolution. So currently, path resolution is pretty lame because we walk the directory structure either from the root or from like the relative starting point that you're using, like the current directory, and then we find every little breadcrumb on the way to the destination, but then we throw away all of that information and just give you the final inode that we found. So I'll show you what the API looks like currently. Resolve path. Yeah, so this is the API here, right? That it returns a k-result or an inode identifier, and you just give it a path and a base, which is the starting point, and then some options from the syscall, and then here's an optional out param where you might learn the parent of the innermost inode, or like the parent of the inode identifier that was returned. And this ends up really sucking because in some cases, or in many cases, we actually need that information about like how we got to this path. Certainly when we implement something like what is the absolute path of this open file descriptor, which is currently like a horrendously inefficient operation in Serenity, because since we throw away all that information, we have to reconstruct it, but in the ext2 file system that Serenity is currently using, the directory inode links are like one way. It's like a singly linked list. I mean, not really, but it only goes one way, so you can't go backwards in the on-disk data, and that forces us to scan like the whole file system, like check every inode, like, hey, are you the parent of this guy? And then we sort of rebuild the absolute path that way. And all that said, it would be so much more efficient if when we were walking a path and constructing them, or figuring out like where a path leads, we would remember that information. And the way I was thinking about two different ways of remembering the information. So I was thinking we could have that it would return a vector of the whole path, like every inode along the way. And I think maybe that would be sensible. But then I was also thinking that we could also return sort of a list of objects that every object is a directory, and or every object is sort of a name and an inode, and it represents that entry in a given directory, and then it would also point to its parent, and this way you would be able to find if you have like one of these things. I was thinking we could call it something like a custodian or a custody or something like that, because it's like it describes the relationship that a parent or has over its child, or not, you don't have a relationship over someone, but the responsibility it has over its child, or the ownership or whatever. And then you could basically, when you wanted to find the absolute path of a custody, then you would just have to walk the chain of custody, if you will, backwards. So you would just like go to the parent custody all the way until you hit the one that doesn't have a parent, and then you're at the root. So that's the data structure that I had in mind. So I think we should just try to implement that. So let me clean up this repository right quick. Okay. So let's do something like file system custody.h and maybe cpp. Okay. And then we'll just refresh my creator. And let me write out some kind of class for this. So it's going to be a retainable object. And it's going to have, I guess we can say private first. So it's going to have retain putter to its parent, and the string with the name of the child, and then I guess a retain putter inode, inode, that's the child. Does this make sense? I mean, it can just be called inode, I guess, because in the root case, the root directory isn't the child, if anything, so in that case it makes more sense to call it just inode. And in fact, there will always be an inode, so it should be retained, since it can't be null. Okay, and then this would be something like, those, and we can have inode not const, and I guess we should do that. Retain putter, and finally include ack string. All right, let's add this to the makefile. Okay, and maybe we can fire up a build so that we have everything built. Okay, and oops, I'm not in Vim. Come on. Add a name getter. All right, and then we should have a retained custody create. Should be static, and this will be parent and name and inode child, or inode, and then we'll say return adopt new custody. Adopt custody. It's like these terms are getting really jumbly here, but parent name inode. Okay, and you should be called name and custody parent const string name inode. Okay. So basically the idea here is that every custody owns its parent custody, and then if you were to delete a leaf custody, then it would just delete, it would potentially delete up the chain of custody as well. And then ideally, or I think the way that it should work is that there's only ever one of these, so these are not like I was thinking, should we have these like globally unique, or should they be, it be okay to have duplicate custodies for the same directory entry? But I think maybe not. Maybe these should come out of a global table or something. That would make it easier to do invalidation, actually. Because if you do like a rename operation, for instance, then you want to find if there's an existing custody for that inode or for that directory entry, then we would have to update the name. So yeah, we should probably put these in a global table, but that can be in the CPP file though. So let's see, kernel file system custody. Okay. Custody. Parent name and inode. Parent name inode exciting. And you can just do, I mean, should do something here. So let's do that global thing I was talking about. So let's call it, we should put this behind a lock actually. So lock, static lockable, hash, we're gonna need a hash table. Hash table, hash table, it's a bit tricky, like how do you find one of these custodies later on, but that we're gonna figure that out later. For now, we're just gonna stash them in a hash table. Probably we're gonna need to have a map with some custom key or something, but that's not super important right now. So just all custodies. And because we don't have startup time constructors in the kernel code, then we have to do a little bit of hackery here. So if table, then table is new hash table custody. Okay, return table. Oops, forgot to say lockable. Right, and then we'll say locker, all custodies dot lock. Is that it? Yeah, I haven't used lockable for a while. And then we'll just do all custodies set this. Okay. Oh, resource. Right. And here we want to remove this. And this was actually implicit. Sure. Okay. Well, we will just put it up here. Custody. Okay. So I think that makes sense. Now we just have to have a version of resolve path that would give you a bunch of these instead. So how the hell would that work? Let's see. I guess first we can make a function for that. So okay, resolve or retain custody. Resolve path to chain of custody, or maybe not that, but just custody. Okay, and that would be a string with the path. Inode with the, or no, we should use actually we should use a custody for the starting point. So it would be like that, and then you don't need this because you find the parent custody by just asking for it, and then but we do need, I guess, the options, so I can just say like that. Okay. Let's just forward declare that. And where do we do this? So let's go and like get, I'm gonna do something really lazy here. I'm gonna put some code into getGid that will trigger this, because then I can just run ID and it will run getGid, but nothing else would use getGid. So let's see. We'll do something like VFS resolve path custody. Get the home directory, and it should be like CWD custody, I guess. Or actually, we can even start in the root custody. Okay. And we'll say no options, whatever. Result if result is error. I guess this thing should be public actually, at least so that we can call it from get good. Okay. Just see what we do here. Gotta invent that, by the way. Okay, so what we want to do now is for auto current, let's say result.value.footer. Okay, and then we'll say something like custody name. Then inode will be something like this. File system ID and inode index inside that file system. Okay. Right, so that will just be a matter of doing this and then current inode society current inode index. And current is a terrible name because current is a global kernel symbol that means the current thread, so let's just call it custody. Oopsie. Wow, look at this big unsorted list of includes. It's so tempting to just resort it right now, but I'm not going to. Okay, so everything here kosher except this guy, so we need to have a custody root custody. Create one of those on demand here, so that would be no parent, name is I guess nothing, and inode is root inode. That makes sense. I think that makes sense. Need to do some including here. Alright, so how the hell do we resolve to one of these then? Let's look at the current resolve path. Right, so we just need that function. So currently a resolve path to inode we'll call resolve path. So I guess this is the one that we want. And we are going to copy paste and make the new good version, and then eventually we can get rid of the old way of doing things. Custody, resolve path to custody. And we didn't need the out param there, so we'll get rid of that. And we can get rid of that here too. so what does this function actually do? Let's strip out all of the debug stuff and we can actually read it. Because this debug stuff is ancient anyway. I don't remember the last time I turned it on. It's like one of the first things I was debugging before there was even a kernel. So let's just get rid of all of it. Okay. So how does this work? And custody base. Okay. So first, if the path is empty, then that's invalid. Fine. And then if the path starts with a slash, then we begin from the root inode ID. Otherwise, we start from base inode identifier. Okay, maybe this thing should be called ID. Oh, who cares? Not right now. Okay, and then the parts are the different components of the path. So like everything in between slashes, right? And we iterate over the parts. And if the part is empty, then we break. So I guess that's when we leave. So then we get the crumb inode. So crumb is one path unit, I suppose, like a breadcrumb. And then we get the metadata for that crumb. Check if it's a directory. If it's not, then we say, hey, that's not a directory. Parent of is not directory. Okay. And if we cannot execute this, then we say you don't have the access denied, like you can't execute this directory. Then this now becomes our new parent, and then we do a lookup inside this parent looking for the part that we're iterating over. And if we don't find something, then we say, hey, there was no such entry. And then here we do the mount business. So we look, hey, is there a mount hosted at this particular inode? So is this directory hosting a mount, basically? If so, we sort of transparently descend into the guest, into the hosted file system here. Right, and this is the trickery to escape a mount if you do a ... in the mount root, in the guest file system root. Okay. Yeah. Oh, it's kind of confusing. Okay. And crumb inode is, then we go into the next crumb. Get inode. So the crumb ID changes, right? Because we're switching parts. Wow, this code is kind of confusing to follow. All right. Well, I suppose what we want to do is to, whenever we encounter a new thing, we want to push something onto our chain of custody here. So custodies, I'll call it custody chain. Can give it a little bit of inline capacity actually. So maybe we can avoid a heap allocation. And Where do we push? Oh, I just realized one thing, that if we're starting from a relative offset, we should actually include that relative offset in the chain of custody. So let's do something like for custody. Yeah. Oh man, and actually we want these to be backwards, so I'm just going to do prepend, even though it's not efficient. I don't want to make that efficient right now, so we'll just do this. Fix me. Pending here is not efficient. Fix this. Okay. Okay, so now for every step of the way, we're going to do something like custody chain dot append custody create custody chain dot last dot guess like that. We can even say like this actually. Just do like that. Or no, let's do it this way. And the name is going to be the, what are we calling it? Oh, part, right, part. Part, and inode is the crumb inode. Okay. And now we actually need to make sure that there's always a last entry in this, so it can't be empty. So in the root case, we have to populate it as well. So that would just be base. Right. Okay. Cannot do that. Well, okay. Don't do that then. Can we do that? Why are you this way? What about that? Does that work? I don't know. I don't even know if that did work. That's a hideous way of doing that, though. It's not actually making it better, is it? Maybe it is. Return crumb by v. Right. So here we want to instead return the chain. So return custody chain last. And 767. Custody star. What? Oh, custody is not. Shit, yeah. Okay. This is not going to work. Yeah, it didn't work. So, what the heck did we learn by that? I guess we should get some kernel symbols so that we can get a proper backtrace. crashing here. Well, where's that? Plop. And debug printf. Great. So custody, I couldn't find region for. Seems like we are doing a null pointer deref when printing out these custodies. So custody like that is here. So I suppose that, oh, I'm just screwing this up. Forgot an argument. Wish you would tell me about that, GCC. Okay. Right. So down here we can see that the custody chain is unknown, home, and then empty, and this is indeed the root inode. So it's pretty cool. We're getting the actual proper chain. Great. So how do we make use of this? Maybe the first thing that we should do is to actually commit this into a separate commit. Let's do that, because otherwise this might get a lot of hand. Finally, make file. And we don't commit this stuff, right? So we'll say kernel, or even file system. Add a custody class that represents a parent. Hold on. Parents guardianship. Parent child guardianship. Custody is kind of a directory entry. Abstraction that represents a single entry in a parent directory that tells us the name and child inode. And let's okay. Child inode. We'll just put it that way. The idea here is for a path resolution to produce a chain of custody objects. Right. So I guess we should try to make use of this. So in file descriptor, for instance, instead of storing the just the inode, we can store the custody. So do like this, custody, and let's see. When you create one of these, you should pass in the custody. Do we actually do that ever? File descriptor create. Yeah, we're passing in the inode here. I guess we could just pass in the pass in the custody instead. So resolve path to custody, and then we'll say custody or error, and of course we need to change that in more places. And this is now custody, and auto inode is custody inode, like that. We can say like this, like that. Okay. Blah 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 blah. Okay. Blah, blah, blah. So, is that cool? Is this gonna work at all? Let's say that keep the old way of doing things, but we also add the new way. So like that. And then this guy will do, yeah, we can keep the inode thing as well, actually, for now. Okay. And when we are creating one with a custody, we will compute the inode. So custody, okay. And do we have a constructor for that? We don't, because, oh, this guy just creates an inode file, actually. Oh, interesting. Okay, so that would just be like create like that, I suppose. Okay. And in this case, we are gonna tweak it a little bit. So we'll say like descriptor. And we'll say set original inode custody inode. Wait, that's not what we're gonna do. We're gonna do set the m custody. That's what we're gonna do. Cannot be assigned. Well, that's an oversight. Operator. Because it's copies. Really? And booster D. Yeah. Well, what's wrong with you, retain putter? Operator. What am I assigning to it? Oh, it's an amp. Oh, right. So it's, I'm assigning an R value reference. That's why it's not working. So let's make that work, I guess. So, but wait, no, this is the R value reference operator. What the hell am I thinking? But I'm not assigning an R value reference then because I'm not moving it. Oh, see, I'm not fast in the head today. Okay. Right. Then we'll have the custody here, and then we could potentially do a fast absolute path. So if I'm custody, then we can do this get you thing. How do we do that? I mean, this is going backwards actually, but we can do something like custodies. Vector, custody chain. We don't know how many, so let's just do that. Custody chain dot append. Started them custody and go through the parents. Okay, and then we'll iterate backwards. We don't have string builder, so we'll need that. Okay, now let's iterate them. So, oh, we don't have a backwards iterator actually, so let's just do this. Custody chain size -1. Oh, I guess like that will still continue, right? Okay, sure. Custody chain. Wait, what am I doing? Custody chain I. I'll start with append slash. Okay. Wait, what's in the custody chain? Oh shit, right. Okay, and then we'll return builder to string. That's pretty cool. Okay, so absolute path made from custody chain is this. Virtual file system is not even compiling because what did I do? I made you upset here. Right. Okay, you're right to be upset. So we're gonna pass the root custody instead, and we're gonna pass the CWD custody, which we have to create. I need to do that in a bunch of places. So should we just do everything in one big go? Let's look at what the process CWD custody would get to look like. So currently we track the working directory inode and also the executable inode, but we could instead we could track the CWD custody. Maybe we should have the executable custody too, actually, because that would make implementing the proc PID executable straightforward. Yeah, let's do that too. So let's do custody, executable custody. Custody is a really weird name for this, but I'm kind of committed to it now. Let's see. Hang on, where are you? I guess I'm not super committed to it, but that's the name that I'm going with for the moment. So what the heck does CWD inode even do? This is retarded factoring. Oh, thank you, past self. Okay. Great. I guess CWD custody, we can just do, well, if there's no CWD custody, we just do what this guy does and get the root custody. That's the fallback. Okay, and then normally I guess you get the custody in exec or something like that. Or yeah, what the hell am I thinking? We get it in exec. We also get it in change directory, obviously. So here we are going to want to. This is a really weird way of doing this. Open directory gives you an inode back. Interesting. Should really give you a custody back. I guess it's not so difficult to do that. We have all the components. Okay, let's just do this wholesale then. Save custody. And if so, then we also have an inode, and that would be the custody inode. And we can then use dots. Fucking love dots. More dots. Dots. Okay. And of course course, that doesn't match the definition. None of these are going to match the definition, but we are not going to need those. So, yep, we are going wholesale. Fuck it. Custody, 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 custody. This is going to be a big patch. An absolute path, right? Yeah. Okay. Now we have a few things to deal with. Custody. No, what am I doing? Not like that. Where did you go? Custody. Then can we call base, and then this will just compile again. Give us a file descriptor, right? Okay, so hopefully in many of these cases it will just compile with the change. If we tweak it slightly. Okay, and we have it open here. Now taking a custody base. Good for you. And that's how that looks like. Solve path to custody, and oh, this logic has to be different actually, yeah. So let's see, if system found error. Okay, and then we'll say auto custody is value. If custody parent. Wait. Does this make sense? Make nod. Resolve path to custody. If we don't find it, then it would give us an int anyway? No? I'm not really sure what this code is thinking. Let's work that out separately. Oh, wait, hold on. So if the error is not int, sure, but if the error is int, but we do have a parent. Oh, so the old thing, what it would do is that it would, that's what it was doing with the parent ID thing. So if it didn't find something, if it didn't find the thing you were looking for, it would still give you the parent, like the incomplete information. Fuck, I guess we still need that, actually, if we want to keep doing things the way that we were doing. So, okay, well, it's nothing more than just accepting our fate and including that thing again. Parent ID is number. Okay. Not many places to fix, so I guess null putter, null putter. Here we get the parent, and here we didn't care about either one, and these are all good. So then implementation. Put the implementation thing back again. So that was temper inode parent. Oh, what the hell was the parent thing anyway? Oh, I guess we have to cheat and look at resolve path. Inode identify parent to be like that, right? Okay, so hold on. This was the header, or the prototype declaration, whatever you call it. Right. Okay. And how did we populate that? So that was div parent ID. Set it up there and down here. So after we get the metadata, before we check is symlink. Right. And same thing up here. So if parent ID, is Chrome ID. Okay. All right. Gotta do so many of these, so let's just try to plow through it. Custody. And oh man, wait. Resolve path inode was doing it differently. Oh, it was doing this. Guess it was nicer to be able to do that, actually. So we'll start out by saying, oh, actually, hold on. So we'll do that, and that would be the parent. So the parent is get inode of the Chrome ID. Okay, ugh, I'm just thrashing around here, but we are almost back on track. I just confused the prototype a little bit. Okay, and then let's go to the definition and tweak that to be a retain pattern inode parent. Yeesh. Okay. Now process. So basically everywhere that we're doing CWD inode, we're just going to pass CWD custody instead. Yeah, so it's probably just a matter of doing this. So one of those didn't work out the way I thought. 1001. CWD custody. Oh, interesting. Getting absolute custody, right? Get. Guess we can say that the custody itself can tell you its absolute path, because why not? String absolute path. Okay, it's beautiful. String custody absolute path. Okay, and we need the string builder. We don't need that in file descriptor anymore, so we can get rid of that. Okay. Where were we? Process 116. What's wrong with you? Oh, right. So then get CWD, it just becomes a matter of doing CWD custody to absolute path. And I guess it shouldn't have an error actually, so we don't have to worry about that. We can just say auto path is this. That's quite nice. Okay, since the root custody don't need to dereference that, it's already a reference. Of course, this is gonna really go to heck when we get to the VFS file, but right, so M custody doesn't make sense here. We want to use this. And no matching member function for that. Because it's const. So, const custody. Okay. All right, so now we got some work to do. So, let's just start at the top. 226. Create custody base and resolve path to custody. And make clear, gets one of these, and resolve path to custody. Alright. These are pretty straightforward actually. Oh wait, hold on, what am I doing? Change mode inode. What do we really want to do with that? Oh, it's fchmod. I guess that thing should still work that way, so we shouldn't change them. So fchmod should really keep taking an inode. Maybe we should rename it to fchmod so that you can see what that is. Okay. Custody, and then this is no longer going to give us an inode. It's going to give us custody or an error, and custody, and auto inode is custody.inode. And start that. Okay. No metadata in that. Right, so shit, here we gotta do some stuff. Old inode is, or let's rename these things. So this is the old custody or error. And the old inode is old custody. But is that actually used in any more places though? No, we don't want to rename that, so just do this, old custody, and old inode is the old custody inode in the rename operation. We got a dereference, and then we can switch to using dots, which is very nice. And here we can just amp that guy, I think. Oh, right, because new inode is a custody still. Alright, so we gotta fix up a few things, but nothing major. Let's rename this guy too to new custody wire. And do that. New custody. we can't compare those, so we can't do that. Right. Great, so we're next, 285. Hang on, it is custody inode. Okay. There's a fair bit of stuff to go through. I'll just keep churning. No, almost trying to do it again here. Wait. Didn't I just look at this? Chmod. Oh, did I forget to rename it? Chmod, yeah. Okay, so then 394, drone. Custody, and this is custody RAM. And the custody is this, and then is custody. So this is like kind of repetitive and not the most interesting thing. I don't really know what kind of commentary to do while I'm doing this because I'm just kind of like updating everything to reflect the new way of doing things. But I guess I'll just keep plugging away here. We'll eventually get through it. 1. Maybe I should be using the, actually, because QCreator tells me that these are red lines here, so I don't know why I always go over here and try to build. That's kind of a stupid workflow, actually. Okay, so let's learn from that mistake. Existing file of error, existing custody error. Well, I suppose we're really only interested in the result anyway. I'm interested in if it's an error. Do we ever open the thing? Symlink, no. Well, okay, well, whatever. That's okay. Then here, let's change that custody. Just rename this guy. Okay, let's use the search and replace here. Jesus. Oh, went too far there. Parent inode. Okay, what else we got? Here, parent inode. Right. So let's try to use the red over here. Some warnings. Okay, here we go. Yeah, that's much better workflow. What was I thinking? Okay. Isn't there a way to rename under symbol? Rename symbol under cursor. Control Shift R. Can I just use that? Okay, let's try it. Oh, it works. It's so cool. I'd rather have it be Alt Shift R now. Okay, that's better. So, custody. Learn your editor, friends, and customize it so that it fits you even better. You won't regret it. this one left, according to QCreator anyway. Okay, and then use the new thing. And that's the old custody. That is old custody.inode. Okay. 816, huh? Wait, oh, there was red down here, I just didn't see it. Is not contextually convertible to bool. Parent is, oh, am I overloading the word parent in this function? Wait, where were we? 816. Yeah, okay, so parent is already used for something else. Okay, so let's call it like parent, I know. Or what does the other one call it? Yeah, it calls it parent inode. Okay. So let's use that. Parent inode. 313 is this, because we want to return the custody instead. So return the custody. Wow, it built. Come on. Wow, that booted a lot farther than I expected. So let's just get a clean build. And then let's see what's going wrong. So are we doing auto inode anywhere? Oh, that's so slow. Okay, oh, we're not. So that's good. As we can see, did we have any like obvious errors here? Shell crashed. Couldn't find blah 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 in select. Null pointer deref here. I mean, we don't think we still have the kernel, but maybe we do actually. Yeah, stir copy. All right. We'll see with the fresh build what we get. Come on, G++. You can do it. Okay. So the shell dies and gets Savada. Get current working directory. Right. So I bet that's because we never. I mean, let's do one thing at a time. So I think we definitely forgot to set up the current working directory. Maybe that's set up in the constructor here. Yeah. So when we construct the process, then we pass in the current working directory. So let's do like pass in the custody instead. Let's see, wd custody. Process. And that would be a custody like that. And you will be there instead. And you don't like me because 231 is a call to this guy and do that. So we pass in the, we want child processes to inherit the current working directory of the parent. So CWD right. So in this case, we're going to do this instead, and CWD custody, and otherwise we just get the root custody. Okay. I wonder what mcwd is used for now. Let's ask you creator. Nothing. Okay, well, let's see how it fares. Still crashing. And let's make sure we have the right symbols. So what did we screw up? We are in getCWD. I'm getting a null pointer deref here. Absolute path made from custody chain. Right, so double slash there. That's a little unaesthetic. But I suppose it's not the end of the world, although we should fix it. Custody. We can just skip the first entry actually, so we should probably do that. Wait, no, we shouldn't do that because here's the right. So wait, I'm not doing this right. So let's skip the root. Okay. Of course, it's still not perfect, but at least we skipped the root directory here, so this looks right. Okay, so we are crashing here. Done. Is that still stir copy? Yes, it's stir copy. Get CWD. We're doing a stir copy to the buffer with the path characters. Why is that failing? Because we can't read from a null pointer. Because I'm calling toString on it to print it. Does that mean that we are... Okay, so calling toString on a string builder will clear what's in the string builder. That's... See, I knew that because I made this thing. It's just that I forgot about it. Okay. Look at that. So that didn't work right. We're in slash, but we are still here. So cd slash doesn't help us. We're unable to get to slash. That's not very good. Home non. Okay, here can we get etc? Yes, we can. And we can go home. Dot is broken, but let's see if we can do some of those things. So what the heck happened now? Absolute path. Oh, we're still doing absolute path for inodes. Oh, because of the executable. Right, so every process also knows which executable was used to spawn it, so we should also get rid of the old way of doing that. And that would just be, get rid of these guys. And executable custody. Let's say descriptive custody. Okay, we almost got it. We just have to expose the custody on the file descriptor so that the process is able to retrieve it. So custody, return m custody putter. Okay. Now we should be able to get the executable that way. Of course, we should also get rid of these old things. So for the proc fs, proc pid cwd, we'll just do handle process. Jesus, so itchy. Process cwd custody dot absolute path, and we'll include custody here. And we also had executable inode here, right? So that would be executable custody. Right, so here we can just do like that. And we'll say custody, dot absolute path. Custody, absolute path to byte buffer. Okay. That's simple enough. Still have a bunch of stuff using cwd inode, so, oh, just that one place. Just the implementation of it. Okay, so what's it here? What are we doing wrong? Passing a custody to an inode star. Because the process constructor, I didn't change the constructor to take that as a custody, right? So there we're good. And oh, those things are in the wrong order. I mean, it's not the end of the world, but let's fix that up. I don't know why I changed it in the header. I could have changed it at the construction site. Okay, so you don't like me. That's understandable. We can just return this to byte buffer. Right. Okay. Cool. I mean, the path is wrong, but it is cool. Okay, where are these things? They have the right path. So we ran out of life here. Because why? Doing a read entire file. Wait, what? This backtrace doesn't make any sense. It's a bit annoying that you have to regenerate the file system to be able to get the kernel symbols in there, but it trips me up a lot. Okay, so then we're failing because we're doing a read link. And pitfd, doing absolute path. Inode file absolute path. Oh, okay, so I guess there are some situations where we have a file descriptor that doesn't have a custody. Create, right, so we gotta look for those. So, I guess it's all here, really, like in the VFS. We have to actually give it the custody. So we'll say set. Oh, hold on. Script. Oh wait, hold on. We're not actually returning that file descriptor. What am I thinking? But this thing has the wrong name, so let's at least fix that. And we are constructing it with the custody, right? That's okay then. So this is what I was looking for. New file. Creating a new file, we should make a new custody for that. So that would be new custody is custody create new file. Wait, hold on. Parent inode. No, it's the parent custody that we want. Jeez. So we have that here. Existing file or error. So I should. Forgot about my keyboard shortcut there. Okay, so existing custody or error. Dot value dot footer. Because that's the parent. And then the child name is p.basename. And the new file is the new inode. And then we can just do this, I think. That. Yeah. Okay. File descriptor. Okay, so is this actually used? Yes. For sockets, peers. For inode, this is what? Open. Okay, so here we have to do it as well. This is open, where we open some file, then we have to put that custody in the file descriptor. So that would be auto descriptor. Descriptor set. Why do I keep blanking out on this? Create custody. No? Okay, so now we have a problem. And what is it? Create fails. Because custody is an error. Oh shit. Let's see. Well, we checked up here that it shouldn't be an error. Oh wait, no, I'm not there. I'm in create. VFS create, sorry. So I'm here. And this is the new custody, and that thing is failing. That value, where's that value? Existing custody or error. So what was the parent inode? Oh, the parent inode is here. Oh, interesting. So I guess we don't have, when we're creating a file, then we don't just want the parent inode, but we also want the parent custody, actually. Interesting problem. Okay, so I kind of messed that up. I should have, I mean, didn't so much mess it up, but I want it to be the parent custody. I can get the inode from the custody, so that's fine. So how do we get there? Like that. Okay. Custody, parent custody. And then the way that we do that is that we just custody chain that last. See, that's actually a more sensible signature, too. I like that better. Okay, then we do it like this. Okay. Yes. So now we have to find all of these plentiful users and look at them. So custody, parent, custody. There was no parent custody. I think that makes sense. These are really verbose. So let's do auto parent. I know what it is. And like that. We just gotta go through this one more time, change it all up. Okay, and now we say parent, auto parent, I know it is parent custody, I know. And this is what we replace. Great. Custody. And if there's no parent, then blah, blah, blah. We're getting there. I know it is old parent custody. Okay. Almost made a mistake. Parent custody. I know that. Okay, and like that. Let me just do this one too. Okay, see, not that much red remaining here. Right, and then parent. I know it is parent custody. All of these things are starting to just blend together in my head now. Starting to forget what's what. Okay, and you go here, and you go here. But then change. So, not that. I mean, not yet anyway. Is this the last function that we have to change? Please be. Parent custody. No, that was a mistake. What am I doing? Parent inode is parent custody inode. Okay, then we can just get that and that, and then are we good? Don't spot any red here. Whew, that was tedious. And now we still crash. I guess we didn't really make use of the new thing. Create. Oh, that's super overloaded. Create. No, VFS create. Right. So we have the parent custody. That's the guy that we want to use here. So the parent custody dot. I mean, actually, it's the parent inode. No, it's the parent custody. What am I thinking? So, what are you? You're a retain putter. It's beautiful. Okay, so we have everything. So now when we create a new file, the parent custody will point to the right place. Okay. See, the executable is, I mean, it's all messy because it doesn't go to the root correctly, but it somehow confuses my home directory with the root directory. But we were able to do that. But then we screw up here, and the backtrace is wrong. So in file descriptor, I'm interested in why we don't have custody for some files. So let's say that file descriptor absolute for empty without custody. File type. Let's see what kind of, no, not close. Class name. See what kind of file. Oops. What kind of file that we are dealing with here when this happens. Because if it's just an inode file, then something is not right. Okay, try again. Here we go. And it's an inode file. Why are we having a file descriptor with an inode file without the custody? Well, one way to figure that out is to just not allow this. And that fails. Oh, I mean, it fails because it's still defined even though it's not declared anymore. So let's just do that. Nobody needed that. Okay. So that didn't tell us anything. I guess we're coming in this way then. We're coming in here with an inode file. Let's see, assert file is inode. And then I want to see a good backtrace. So, oh gee, this is too many jobs. Okay. Clone. Clone is doing it. So I guess when we fork, then we clone. Clone is not copying over the custody. Wow. That's easy to fix. Custody got copyright. Cool. And who else is doing this? Oh shit, right. Because I'm asserting in there, but I guess now it's okay because that's probably the issue anyway. So proc 11 FD OSL. Look at that. That is really cool. And we can even see all the files that are open. I haven't been able to do this for a long time because of this has been so crashy because it just tried to, like I was talking about earlier, forever ago, that it would have to like enumerate the entire file system just to figure out who's the parent of who, or whom, or whatever. So cd / definitely broken. Let's see, CWD custody. So we would be here. Oh, I see what the problem is. If the path starts with a slash, then we just append the base. That's not right. For absolute path, we should append the root custody. Ta-da! Okay. I'm in slash. That's very nice. Okay, finally. Let's see, dot. It just works. Okay, so let's go to here. That's super correct. Very, very nice. And what's in FDs? This information is just super correct. Very, very good. Okay. So, shit, it's finally starting to work. Now, this is not taking into account, we still haven't fixed renaming. So if there's like an existing custody when a rename happens, because I was thinking about it while I was doing this rote editing here, that the custody has the inode retained, so the inode is never going to go away as long as the custody refers to it, and that's good, right? Of course, the inode doesn't keep his custody alive, so there's no retain cycle. Again, that's good. But since the custody keeps the inode alive, then when we are renaming an inode in this parent, then we really need to find every custody that points to this thing and update his name. And what should happen when you do a delete? Like if you remove the thing from the directory. Well, I'm not going to figure all that out right now, but I'm going to commit this locally. Well, I'm not going to push this stuff to the, I'm not going to push this to the master branch until I have everything working, because that wouldn't be very nice to the poor people who are using my master branch to work on. But I'm going to commit this because at least I've made some progress here. So let's say file system port. All the file system code over, port all the code over to let's say most of the code, because probably, I mean, there's a bunch of code using inode still. Process, working, process. current working directory is now in custody. Likewise for the currently forwarding process. This unbreaks proc paid 50 has not been working since we made the file system bigger. This still needs a bunch of work. For instance, when renaming or removing a file, we have to update the relevant custody links. Okay, but I'm going to do that. And I think I'm gonna stop recording here and get back to this a bit later today. But this seems like a natural point to turn off or to stop in the video, because at least we were able to make this stuff work. But it's not finished yet, of course, but it's in a better place. Okay, so if you made it all the way here with me in this video, then I sincerely thank you for watching, because this was a rough one, and we didn't even finish everything. But yeah, so thank you for hanging out while I do this refactoring stuff, and I hope to see you next time.